Hi, this is Miss Litton, and this is my wonderful honors bio students. Time, say hi. Hi. We're here at lunchtime, and it's Friday, and we're really excited. Okay, so first thing I want to talk to you about on this chapter is when we look at the abiotic and biotic factors in the environment, the very first thing I want you to get, and here's one of them I've given to you, is producers. What do we call, what are all the different categories of all the different types of organisms that you would have in any one environment? See if you can remember those off the top of your head, all the different categories. And this picture right here, you should be able to identify all the different types of living organisms. What are the two big categories you could have? Producers, good. And what's the other one? And consumers, good. Okay, if I was going to break the producers down into two categories, what would they be? Autotrophs, good. And what? Chemotrophs. Autotrophs, well, producers are all autotrophs. That's maybe not what I wanted to do there, but that's another good name. What's another name I could put here? Phototrophs, good. What do phototrophs use? The sun, yeah, light. Whereas chemotrophs will break down something like hydrogen sulfide and get the energy from that. You would find them, let's say, in a cave or in soil or a hydrothermal vent, okay, is where you'd find a chemotroph. Consumers, what are the different kinds of consumers we could have? Okay, so you said primary, what's another one? Secondary? Tertiary, sure. What's another, when you say primary consumer, what are you referring to? An herbivore, good, an herbivore. Okay, so you could have an herbivore, and herbivores eat what? Plants. What would a secondary be? It could be a carnivore. And you have different levels of carnivores, right? So a secondary consumer would be a carnivore that eats a herbivore. And a tertiary would be a carnivore that eats another carnivore that eats a herbivore, right? Now, what do you call something that eats both plants and animals? Omnivores, good. Okay, perfect. All right. Now we need, if I gave you this, you could identify each of the organisms in this process. Yeah, that's pretty easy. We have another member of a consumer. Who is it that we're missing? Starts with a D. Decomposers, good. So your primary decomposers are going to be things like bacteria and fungi, but you also could have detritivores. Remember that part? Okay, that eat detritus, dead things, like at the bottom of a cave or something like that. Whereas, remember the two different kinds of food webs? Did you see my bee sting? Oh my. Zero period outlined it for me so we could see if it grows. We're being very scientific. Oh, it's killing me. Food webs, some of them could start with phototrophs, or some of them could start with detritus and dead things, right? When we looked at food webs. Answer me this. We turned on 19 number. For some of you, this will be the second or third time you've done this, so you should get 100%. 19 number. Dandelion yellow, shamrock. Okay, before I stop it, tell me what could we categorize this stuff as? Autotroph. What's another thing we could categorize this stuff as? What? Producers. Good. What's another name we could use? Phototroph. Good. What could we categorize this guy as? Herbivore. What else could we categorize him as? A consumer. What kind of consumer? A primary consumer. Is there anything else we could categorize him as? Heterotroph. Good. Do we hit them all? Okay, so let's see what people said. Darn it, some people said E. So producers are, what was the producer in here? The grass was the producer. So producers are, yes, autotrophs. They cannot be an autotroph and a what? Herbivore. Okay. Check with your neighbor, see if they got it right. Good job, Shocking Pete. Okay, next. Could the person in the darkest seat, or if you're not in seats with the darkest shirt, if you're in a group, could you please distinguish food webs and food chains? Food chains. What's the difference between a food chain and a food web? Okay, if I said the bunny ate the grass and the hawk ate the bunny, or sometimes the fox ate the bunny, and the birds ate the seeds from the grass, what would that be an example of? Okay, a food web. Because what are all the things that I said? I said you had the grass, and then who ate the grass? The bunny ate the grass. Okay, so you had energy going from the grass to the bunny. What else did I say? Oh, the hawk. Okay, the hawk ate the what? The bunny. Okay, who else could eat the bunny? The fox could eat the bunny. I don't know. Okay, so the fox could eat the bunny. What else did we say?
Birds eat the seeds.
The birds are eating seeds from the grass. So do you see how that's not a food chain? That is a food web. Because there are multiple places that energy is going. Now, if I wanted to talk about trophic levels and this beautiful, beautiful drawing that I have right here, who would be at the first trophic level?
Grass.
The grass. The plants would be at the first trophic level right here. This is the first. The first trophic level is always going to be the plants or the producers. Who's going to be at the second trophic level? The bunny. And that would be categorized as a what? Herbivore. Good. And who would be at the third trophic level? The fox, the hawk. But the hawk is also eating at the first trophic level as well, right? Okay. And I could stack these trophic levels up into a what? Into a pyramid. Okay. If I did a pyramid like this, who's at the, what level is at the first? Or is that the first trophic level? Good. And those would be your what? Producers. And then you would have your herbivores. And you would have your carnivores. What could I classify these as together? Consumers. Good. Who's missing? Why is this a bad model to use? What's missing? Decomposers. Why is this a good model to use? There's fewer herbivores than producers, right? Generally speaking. There are fewer carnivores than there are herbivores, yes? But why is this a bad model in that way?
It didn't show the 10%.
The 10%, right? Of all of these producers right here, about how much of that energy gets passed on to the next one?
10%.
About 10%. And of all that, about 10% gets passed on. We all right on that? So we talked about the pyramid of numbers. We talked about the pyramid of biomass. Generally speaking, all your producers are going to weigh more than all your herbivores, and all your herbivores are going to weigh more than carnivores. But another way to look at it would be to look at the pyramid of energy. Okay, good, good, good. We did all of that. Riddle me this. Okay, atomic tangerine. Okay. Oh, what did somebody put? Okay, they forgot E. E, a snake is a consumer. Okay, that's the only thing they missed. So most of you got that one. Okay, look at the picture really well. You ready? You see everything you need to see? Okay, tickle me pink, mango tango, atomic tangerine. I want to cut my arm off. Okay, what is C? C is the frog. Okay, the frog in this case is not an herbivore. He's not eating plants. What is he eating?
Caterpillar.
Yeah, he is eating this caterpillar. This caterpillar is coming to him. So he's not an herbivore. He is a what? Oh, you got lots of weird words out. He's a carnivore. He's eating, right? If he's eating an animal, okay, then that makes him a carnivore, right? Okay. So there's some other ones there, but I think you guys get that. So I want to move on. We did this, yes? Feel comfortable? And we did the 10% rule. Okay, and let's do this. And I have a bunch of questions at the end I want to ask you too.
Sorry.
Let's go dandelion yellow, robin's egg blue. Okay, I can't wait anymore. Dandelion. Okay, thank you. Yay! Hyundai. You were the first 7th period Hyundai. You got 1, and it was honors. Okay. Let's get another one. Let's go orchid. Yay, you got 2. Very impressed. All right, good. Moving on. So then, oh, there's one more. You could get 3. Okay, mango tango. Mango. Tango. Okay, well, we got 2. That's good. We got 2. All right. Next, we went on to the.
It said the was it the American Medical Awareness? Do you know where I would join that?
You know, sweetheart, they are meeting. Anybody know where? I think they meet on Tuesdays, sweetheart.
You can sign up in the pavilion.
You can sign up in the pavilion.
Really? Do you know where there's a circle?
It's like the second one. Yeah, it's like the second one. Yeah, like the
Second row back.
Okay, thank you.
Okay. All right. So then, biochemical cycles. I think water cycle. You're not. Oh, yeah, we're good on that. I think on water cycle things you want to. Do you need me to go over this? Reservoirs where it's stored. Exchange pools where plants or usually autotrophs access it, and then community passes through living things. On your water cycle, keywords you would want to know. Tell me, what is it when water evaporates out of open plant? Okay, good. Transpiration, good. What do you call it when it goes from a liquid to a solid? No. What do you call it when it goes from a liquid to a solid? Freezing, yeah. What do you call it when it goes from a gas to a liquid? Condensation. What do you call it when it falls from the sky? Precipitation. Good. What do you call underground fresh water? Aquifers. Good. Okay, so you got that part down. I don't think that's going to be difficult. Hola, ¿cómo está?
Are you leaving right after this?
No,
Oh, I thought this was your early day.
No, I have fossil, 5th grade. All right. And then there was another, oh, how much of the water is fresh? 3%. And most of that is up in what? Glaciers. Good. Okay, so I think water cycle, you feel comfy? And then how does man screw up the water cycle? Pollute it. Yeah. We pollute it. Or what is it when you like have a whole bunch of dirt that's missing and there's a big dip in the road? Sinkholes. Good. All right, we're good on that. Okay, so let's move on to the phosphorus cycle. This is a sedimentary cycle. Phosphorus is stored in rocks. What normally takes it out of the rocks? Weathering. It's a limiting nutrient, meaning there's not a lot of it available, so it keeps everything else in check. When man puts too much of it into the environment, all of a sudden you can get a what? 2 words, starts with an A. Algal bloom. Good. Now we have a lot of algae. They're all doing photosynthesis, which seems like a good thing, but they're going to run out of those phosphates and they're all going to what? Die. Who's going to work on them? Decomposers. And when they do, decomposers are going to require what? Oxygen. And they can take all the oxygen out of the lake as they're decomposing that algal bloom, and that can cause massive fish kill. Good. And that's called eutrophication. So that's how man steps in and makes it bad. Questions, concerns on that one? All right, let's go do the nitrogen cycle. Let's do it together, yes? And if you wanted more help on the nitrogen cycle, what could you do? It's on YouTube. Here we go. Hands in the air, hands in the air. Ready? We do nitrogen fixation, and you form what? Ammonia. Who does that? Nitrogen fixing bacteria. Then you do what? Nitrification. First you form nitrite. Good. Then you form nitrate. And you're going to serve this up to who? Plants. And now the nitrogen is in plants. And who does this nitrification process? Yeah, the bacteria do it. Good. So then you do, why is he looking in our car? Then you form, it's in plants. No, it's not my car, I'm next to it. Plants, and then animal can eat the plants, and then the animals and the plants, what? Die. Who works on them? Decomposers, and they break it back down into ammonium, and then you can do nitrification, forming nitrite, and then more forming nitrate. There's another way to get at nitrates as well, through what? What's that? Lightning. You can do atmospheric fixation, or humans. And what do they make? Fertilizers. Good. And if you're going to return the nitrogen back to the atmosphere, that's called what? Denitrification. Tell your bio, but if you understand that or not. Hi, that is Ellen's car. Oh, it was? Oh my goodness. Oh yeah, yeah. I'll tell her. Oh, thank you. Yeah. He closed her car for her, but he saw baby seats in there, and all of a sudden he's stressed out, like there might be babies in there that we leave out in the parking lot. Okay. So good. Questions or concerns on nitrogen cycle? What's your last cycle? Oh wait, tell me how you screw it up. Tell me how man screws it up.
Burning fossil.
Yeah, burning of fossil fuels. Good. Okay, then the last cycle is the carbon. And the key thing you want to hear or remember about this is, what are the ways we remove carbon from the air? CO2 from the air. How do we do that? Photosynthesis. Good. And then how do we put CO2 back into the air? What are some of the processes? Cellular respiration, combustion, and decomposition. And it appears that we're putting more CO2 in the air than we are removing it, and that could cause what? Global warming. Yeah, so more heat, the excess CO2 is gonna trap that heat in, so the heat comes in, but it can't get out, and then that would be linked to global warming. When CO2 is dissolved in water, what is it called? Bicarbonate. All right, here come a bunch of questions. And I'm gonna go fast so we can get through them all. 3, 2, 1. Aquifers are part of the water cycle because it's underground fresh water. So somebody missed that one, okay? Good job, Chuck and Pete. Three, 2, 1. Yay! Oh, we're back to 1 again. Three, 2, 1. Oh. Okay, now not carbon dioxide, 78% of the air we're breathing in and out of our lungs right now, nitrogen. Okay, can we do anything with that nitrogen? No, that's why we need what? Nitrogen fixing bacteria. Yeah. Okay then. Read it carefully. I sorry about that. She's home. Okay, Mango Tango. Okay, good. Most of you got that denitrification. So you think, I'm at nitrate. Now I'm going back into the air. That's denitrification. Think it out. Look what you're starting. Look where you're ending at. Think about the dance. Nitrogen gas. Show me what nitrate looks like in our song. Nitrogen gas, straight to nitrate. What's that? Oh. You should have a little ha in there, right? Oh, a bunch of you missed it. So think about it. You're nitrogen gas and you're going straight to nitrate. So that's atmospheric fixation. Commit. Good, nitrogen fixation. Yeah, that one's nitrogen fixation. You're going from nitrogen gas in the air to what? Ammonium. Think it through when you're answering so you get them all right. Okay, good. Most of you got that. Nitrite to nitrate is what? Nitrification. Bless you. All of those are involved in the carbon cycle. Okay? Hang on just a minute, guys.
Oh yeah, look, frozen sound. Yeah.
It was all of them. Okay, just so you know.
Wow.
The end, yay! Be super smart.
Can you come back to those two most recent slides so I can
Yeah,
take
yeah.
a picture? Okay, and I got that one. Thank you.
You are welcome.